Hello children, let us solve previous year's JEE questions. First question, if 1 plus I upon 1 minus I to the power m by 2 is equal to 1 plus I upon 1 minus I to the power n by 3, where m and n are natural numbers, then the greatest common divisor of the least values of m and n is. This question was asked in JEE Mains 2020. First step is to rationalize the denominator on both the sides inside the bracket. On both the sides inside the bracket, it is 1 plus I upon 1 minus I. So we will multiply both numerator and denominator by conjugate of denominator. And conjugate of denominator is 1 plus I. So we can simplify it as I to power m by 2 is equal to I to power n by 3. On both the sides, base is same. So we can equate exponents and say that m by 2 is equal to n by 3 or m by n is equal to 2 by 3. Next, we have to find out greatest common divisor of the least values of m and n, where m and n are natural numbers. So we will make a table and write the values of m, n and common divisor. When m is equal to 2 and n is equal to 3, common divisor is 1. When m is equal to 4 and n is equal to 6, common divisor is 2. When m is equal to 6 and n is equal to 9, common divisor is 3. When m is equal to 8 and n is equal to 12, common divisors are 2 and 4. So far 4 is the greatest common divisor for least values of m and n. Let us look out for the next one. When m is equal to 10 and n is equal to 15, common divisor is 5. This looks like greatest common divisor, but it is not for the least values of m and n. So our answer is 4. 4 is the greatest common divisor for the least values of m and n, where m is equal to 8 and n is equal to 12. So our answer is 4. So we will fill 4 here. Second question, the sum of 162th power of the roots of the equation x cube minus 2x square plus 2x minus 1 is equal to 0 is. This question was asked in JEE Mains 2021. The given equation is x cube minus 2x square plus 2x minus 1 is equal to 0. Put x is equal to 1 to check whether 1 is one root of the equation or not. We get LHS is equal to RHS. That means 1 is one root of the equation. We can rewrite this equation as x cube minus x square plus x minus 1 is equal to 0. So that we can take x minus 1 common. In term 1 and 2, we can take x square common. So inside the bracket, it is x minus 1. In term 3 and 4, we can take minus x common. So that inside bracket, it is x minus 1. And in term 5 and 6, we can take plus 1 common. So that inside the bracket, it is x minus 1. Now we can take x minus 1 common in 3 terms. So it will be x minus 1 into x square minus x plus 1 is equal to 0. We have factorized the given equation as x minus 1 into x square minus x plus 1 is equal to 0. This means either x minus 1 is equal to 0 or x square minus x plus 1 is equal to 0. We have already seen that x is equal to 1 or 1 is one root of the given equation. Other two roots we will find from this quadratic equation. Let us say other two roots are x2 and x3. So x2 comma x3 is equal to minus b plus minus under root b square minus 4ac upon 2a. So x2 and x3 come out to be x2 is equal to 1 plus root 3i by 2 and x3 is equal to 1 minus root 3i by 2. So the three roots are 1, 1 plus root 3i by 2 and 1 minus root 3i by 2. Now we have to get the sum of 162th power of the roots. So it will be 1 to power 162 plus 1 plus root 3i by 2 to power 162 plus 1 minus root 3i by 2 to power 162. 1 to power 162 is equal to 1. Second term can be written as 1 by 2 plus root 3i by 2 to power 162. And third term can be written as 1 by 2 minus root 3i by 2 to power 162. 1 by 2 means cos pi by 3. Root 3 by 2 means sin pi by 3. Similarly, 1 by 2 means cos pi by 3 and minus root 3 by 2 means minus sin pi by 3. Now we can apply the Myers theorem in second and third term. So this power will be multiplied with the angles. So it will be 1 plus cos 162 pi by 3 plus I sin 162 pi by 3 plus cos 162 pi by 3 minus I sin 162 pi by 3. So this term and this term will get cancelled and this will be added to give 2 cos 162 pi by 3. This can be simplified as 54 pi and 54 pi is a multiplier of 2 pi. So we can write 2 pi into 27 plus 0. So value of this is equal to cos 0 and that is 1. So value of the expression is 1 plus 2 into 1 and that is 3. So our answer is 3. Third question, let z be the complex number such that mod z minus I upon z plus 2i is equal to 1 and mod z is equal to 5 by 2. Then the value of mod z plus 3i is, these are the options given. This question was asked in JEE Mains 2020. It is given that mod z minus I upon z plus 2i is equal to 1. Using mod property, we can write mod z1 by z2 is equal to mod z1 upon mod z2. Cross multiply to get mod z minus I is equal to mod z plus 2i. Suppose this is equation number 1. Now assume z is equal to a plus ib. So z minus I is equal to a plus b minus 1 into I. Mod z minus I is equal to under root a square plus b minus 1 whole square. Z plus 2i is equal to a plus b plus 2 into I and mod z plus 2i is equal to under root a square plus b plus 2 whole square. As per equation 1, mod z minus I is equal to mod z plus 2i. So under root a square plus b minus 1 whole square is equal to under root a square plus b plus 2 whole square. Square both the sides and simplify to get b is equal to minus 1 by 2. It is given that mod z is equal to 5 by 2. Mod z is equal to under root a square plus b square. Square both the sides to get a square plus b square is equal to 5 by 2 whole square. Put the value of b as minus 1 by 2 and simplify to get the value of a is equal to plus minus root 6. We have to calculate the value of mod z plus 3i and mod z plus 3i is equal to under root a square plus b plus 3 whole square. Put the value of a and b from here to get mod z plus 3i is equal to 7 by 2. So the correct option is option C. Fourth question, let alpha is equal to minus 1 plus I root 3 by 2 if a is equal to 1 plus alpha into summation of alpha to power 2k where k is 0 to 100 and b is equal to summation of alpha to power 3k where k is 0 to 100, then a and b are the roots of the quadratic equation. These are the options given. This question was asked in JEE Mains 2020. By just looking at alpha, you know that this is omega. Recall the cube roots of unity. They are given by 1, omega and omega square, where omega is equal to minus 1 plus root 3i by 2 and omega square is equal to minus 1 minus root 3i by 2. So replace alpha by omega. That will give the advantage of using two identities. 1 plus omega square is equal to 0 and omega cube is equal to 1. So let us start. Given a is equal to 1 plus alpha into summation of alpha to power 2k from k is equal to 0 to 100. Replace alpha by omega and expand the series. So a is equal to 1 plus omega into omega to power 0 plus omega square plus omega to power 4 plus and so on up to omega to power 200. From k is equal to 0 to k is equal to 100, there are 101 terms. And this is GP series. Sum of n terms of a GP series is given by the formula Sn is equal to a into 1 minus r to power n upon 1 minus r, where a is first term, r is the common ratio, and n is the number of terms. First term is omega to power 0, and common ratio r is equal to omega square upon omega to power 0 or omega to power 4 upon omega square. So r is equal to omega square. Number of terms n is equal to 101. So Sn is equal to omega to power 0 into 1 minus omega square to power 101 upon 1 minus omega square. So after simplification, a is equal to 1 minus omega to power 202 upon 1 minus omega. Now we can write omega to power 202 in terms of omega cube, because we know omega cube is equal to 1. So divide 202 by 3. We get 67 as quotient and 1 as remainder. So 202 can be written as 3 into 67 plus 1. So omega to power 202 can be written as omega to power 3 to power 67 into omega. Omega cube is equal to 1. So this part is omega. Numerator is 1 minus omega and denominator is also 1 minus omega. So A is equal to 1. B is equal to summation of alpha to power 3k from k is equal to 0 to 100. So replace alpha by omega and expand the series. So B is equal to omega to power 0 plus omega cube plus omega to power 6 plus and so on up to omega to power 300. Again, there will be 101 terms from k is equal to 0 to k is equal to 100. And this is GP series. But this time we will not apply this formula. Rather, we will manipulate the terms as the terms are already in the form omega cube. First term is omega to power 0, so that is 1. Second term is omega cube, so that is 1. Third term is omega to power 6, so it can be written as omega cube whole square, and value of omega cube is equal to 1. So third term will also be 1. Fourth term is omega to power 9, so it can be written as omega cube whole cube. So it will be 1. Last term will be omega cube to power 100. Omega cube is 1. So again, last term will also be 1. So there will be 101 terms and value of each term is 1. So summation will be 1 into 101. So B is equal to 101. Now we have got the value of A and B. So quadratic equation whose roots are a and b will be given by x minus a into x minus b is equal to 0. Put the value of a and b from here. So quadratic equation is x square minus 102x plus 101 is equal to 0. So the correct option is option A. Fifth question, let the lines 2 minus I into z is equal to 2 plus I into z bar and 2 plus I into z plus I minus 2 into z bar minus 4I is equal to 0. Here I square is equal to minus 1 be the normal to a circle C. If the line iz plus z bar plus 1 plus I is equal to 0 is tangent to this circle C, then its radius is. These are the options given. This question was asked in JEE Mains 2021. Suppose this is the given circle C. PO and QO are two given normals. They intersect at O, which is center of the circle. So first we will solve the given normals PO and QO to get center of the circle. Then we will calculate the perpendicular distance OR between the center of the circle and the given tangent. This perpendicular distance OR will be radius of the circle. So let us start. Suppose z is equal to x plus iy. So z bar is equal to x minus iy. We will put these values of z and z bar in n1. So we will get 2 minus I into x plus iy is equal to 2 plus I into x minus iy. This gives x is equal to 2y. Suppose this is equation number 1. Now we will put the values of z and z bar in N2. So we will get 2 plus I into x plus iy plus I minus 2 into x minus iy minus 4i is equal to 0. This gives x plus 2y minus 2 is equal to 0. Suppose this is equation number 2. Now we will solve equation number 1 and equation number 2 to get x is equal to 1 and y is equal to 1 by 2. So the center of the circle will be x plus iy, and that is 1 plus 1 by 2i. Given equation of tangent is iz plus z bar plus 1 plus I is equal to 0. Rearrange the terms to get z bar plus iz plus 1 plus I is equal to 0. Compare it with the equation of a straight line in general form, which is az bar plus a bar z plus b is equal to 0, where b is purely real, but 1 plus I is imaginary. To make this part purely real, we need to multiply both sides of the equation with 1 minus I. So we will get 1 minus I z bar plus 1 plus I z plus 2 is equal to 0. Now the equation of tangent is in general form with a is equal to 1 minus I, a bar is equal to 1 plus I and b is equal to 2. Now we are ready to calculate the perpendicular distance OR between the point Z1 and the straight line AZ bar plus a bar z plus b is equal to 0. And OR is given by mod a z1 bar plus a bar z1 plus b upon 2 mod a. We can start putting the values. A is equal to 1 minus I, a bar is equal to 1 plus I, b is equal to 2, z1 is equal to 1 plus 1 by 2i, z1 bar is equal to 1 minus 1 by 2i, and mod a is equal to under root 2. So we will get OR or radius of the circle equal to 3 upon 2 root 2. So the correct option is option D. Sixth question. Let z be those complex numbers which satisfy mod z plus 5 is less than or equal to 4 and z into 1 plus I plus z bar into 1 minus I is greater than or equal to minus 10. I is equal to under root minus 1. If the maximum value of mod z plus 1 square is alpha plus beta root 2, then the value of alpha plus beta is. This question was asked in JEE Mains 2021. It is given that z satisfies these two inequalities. So first, let us understand its meaning. First inequality is mod z plus 5 is less than or equal to 4. This can be written as mod z minus in bracket minus 5 is less than or equal to 4. This matches with equation of a circle in standard form, which is given by mod z minus z0 is equal to r, where z0 is the center and r is the radius. Inequality less than or equal to means z lies somewhere on the circle or inside the circle. Let us understand the meaning of second inequality. It is given as z into 1 plus I plus z bar into 1 minus I is greater than or equal to minus 10. We can rearrange the terms to get 1 minus I into z bar plus 1 plus I into z plus 10 is greater than or equal to 0. This matches with equation of a straight line in general form, which is given by az bar plus a bar z plus b is equal to 0. To get the idea how this line can be sketched in complex plane, put z is equal to x plus iy. So z bar is equal to x minus iy. So the inequality will be 1 minus I into x minus iy plus 1 plus I into x plus iy plus 10 is greater than or equal to 0, which can be simplified as x minus y plus 5 is greater than or equal to 0, or y is less than or equal to x plus 5. Consider for a moment y is equal to x plus 5, which is very familiar equation of a straight line in the form y is equal to mx plus c in Cartesian plane. Slope m is equal to 1 and y-intercept c is equal to 5. So this line will make 45-degree angle with positive real axis, its y-intercept is 5 units and its slope is 1. So its x-intercept is also 5 units. So this line will pass through the center of this circle. We need to consider the intersection of this circle and straight line. So which part should we consider? This part or this part? To make sure which part we need to consider, we need to see this inequality again. So y is less than or equal to x plus 5. If you put the values of x as minus 5, minus 4, minus 3, minus 2, then you will see y is increasing. That means when x is increasing, y is also increasing. So you need to consider this part. So z will lie somewhere in this region. We need to find maximum value of mod z plus 1 square. Mod z plus 1 is equal to mod x plus iy plus 1. Mod z plus 1 square is equal to x plus 1 whole square plus y square. Mod z plus 1 square will be maximum when x and y both are maximum. So where should the point z lie in this region so that its x and y values are maximum? It should be at point B. So first we will calculate the points of intersection of this circle and this straight line. For that, we need to consider these two curves. Mod z plus 5 is equal to 4, that is equation of circle. And the line 1 minus I z bar plus 1 plus I z plus 10 is equal to 0. We will put z is equal to x plus iy and z bar is equal to x minus iy. So equation of circle we will get is x square plus y square plus 10x plus 9 is equal to 0, and equation of a straight line as y is equal to x plus 5. We can solve equation 1 and equation 2 to get 2 points. When x is equal to minus 5 plus 2 root 2, y is equal to 2 root 2, and when x is equal to minus 5 minus 2 root 2, y is equal to minus 2 root 2. Since point B is in third quadrant, so x and y both will be negative. So we will consider second point. So value of x is equal to minus 5 minus 2 root 2 and value of y is equal to minus 2 root 2. So mod z plus 1 square is equal to, we will put value of x and y here. So mod z plus 1 square is equal to 32 plus 16 root 2. Compare this value with alpha plus beta root 2. So alpha is equal to 32 and beta is equal to 16. So alpha plus beta is equal to 32 plus 16, and that is 48. So our answer is 48. Seventh question, if the equation A mod z square plus alpha bar z plus alpha z bar whole bar plus d is equal to 0 represents a circle where A, D are real constants, then which of the following condition is correct? These are the options given. This question was asked in JEE Mains 2021. Given equation of circle is A mod z square plus alpha bar z plus alpha z bar whole bar plus d is equal to 0. Mod z square can be written as z bar. This is in the form z1 plus z2 whole bar, which is equal to z1 bar plus z2 bar using conjugate property. This is in the form z1 into z2 whole bar, which is equal to z1 bar into z2 bar. Bar of alpha bar is equal to alpha and bar of z is equal to z bar. Similarly, this is in the form z1 into z2 whole bar, which is equal to z1 bar into z2 bar. Bar of alpha is alpha bar and bar of z bar is equal to z. Now divide this whole equation by A. So we get zz bar plus alpha by A z bar plus alpha bar by A z plus d by A is equal to 0. Suppose this is equation number 1. We know the general form of the equation of circle is given by zz bar plus pz bar plus p bar z plus q is equal to 0. Here I have replaced letters A and B by P and Q to avoid the confusion of same letter A. Here center Z0 is equal to minus P and radius R is equal to under root mod minus P square minus Q. Now compare equation 1 and 2 term by term. So it will be P is equal to alpha by A, P bar is equal to alpha bar by A, and Q is equal to D by A. So radius R is equal to under root mod minus alpha by A square minus D by A. First thing you will notice here is A cannot be equal to 0. And inside the bracket stuff also cannot be equal to 0. Because in that case, radius will be 0, so circle will be a point. So the inequality we will write, this part is greater than 0. Now this is mod z1 upon z2 square. So it can be written as mod z1 square upon mod z2 square. So it will be mod alpha square upon mod a square, can be written as a square if a is real. Minus d by a is greater than 0. Now take a square as LCM. So it will be mod alpha square minus AD upon a square is greater than 0. If a is real, a square is always positive. So for this inequality to be greater than 0, numerator should also be greater than 0. So the condition is mod alpha square minus AD is greater than 0 and a is not equal to 0. Also a is real. So the correct option is option B. Eighth question, the least value of mod z, where z is a complex number which satisfies the inequality exponent of mod z plus 3 into mod z minus 1 upon mod z plus 1 into log 2 base c is greater than or equal to log of mod 5 root 7 plus 9i to the base root 2, I is equal to under root minus 1 is equal to. These are the options given. This question was asked in JEE Mains 2021. First, we will simplify right hand side of the inequality. Mod 5 root 7 plus 9i is equal to under root 5 root 7 square plus 9 square, and that is equal to under root 175 plus 81, and that is equal to under root 256, which is equal to 16. 16 can be written as 2 to power 4 or root 2 to power 8. So right hand side is log root 2 to power 8 to the base root 2. This power can be shifted here. So this is equal to 8 into log root 2 to the base root 2. This is in the form log a base a, which is equal to 1. So that is equal to 8. 8 can be written as 2 to power 3. So right hand side is simplified as 2 to power 3. Now let us see left hand side. Exponent of this whole. Now this can be shifted as power of 2. So this whole can be written as exponent of log 2 to power this to the base e, which is equal to 2 to power this whole. So 2 to power mod z plus 3 into mod z minus 1 upon mod z plus 1 is greater than or equal to 2 to power 3. On both the sides, base is same. So we can equate the exponents. Mod z plus 3 into mod z minus 1 upon mod z plus 1 is greater than or equal to 3. Now cross multiply. So it will be mod z plus 3 into mod z minus 1 is greater than or equal to 3 into mod z plus 1. Now take this to left hand side. So it will be mod z square minus mod z minus 6 is greater than or equal to 0. We can factorize this as mod z plus 2 into mod z minus 3 is greater than or equal to 0. Now this inequality is possible only when both are positive or both are negative. So we will consider two cases. In case 1, we will consider both of them to be positive. So mod z plus 2 is greater than or equal to 0 and mod z minus 3 is greater than or equal to 0. From this, mod z is greater than or equal to minus 2 and from this, mod z is greater than or equal to 3. If we combine both, we can say that mod z is greater than or equal to 3. In case 2, mod z plus 2 is less than or equal to 0 and mod z minus 3 is less than or equal to 0. If we combine both, we can say that mod z is less than or equal to minus 2, which is not correct, as we know that mod is always positive. So mod z should be greater than or equal to 0. So in this case, we will not get any solution. So finally, we can say that mod z is greater than or equal to 3. So minimum value of mod z will be equal to 3. So option A is correct. Ninth question. For a complex number z1, let Rez denote the real part of z. Let S be the set of all complex numbers z satisfying z to power 4 minus mod z to power 4 is equal to 4i z square, where I is equal to under root minus 1. Then the minimum possible value of mod z1 minus z2 square, where z1 z2 belong to S with real z1 greater than 0 and real z2 less than 0 is. This question was asked in JEE Advanced 2020. First we will simplify z to power 4 minus mod z to power 4 is equal to 4i z square. Suppose z is equal to x plus iy. So z to power 4 is equal to x plus iy to the power 4. That gives x to power 4 plus y to power 4 minus 6x square y square plus I into 4x cube y minus 4xy cube. Mod z is equal to under root x square plus y square. So mod z to power 4 is equal to x square plus y square whole square, and that is equal to x to power 4 plus y to power 4 plus 2x square y square. 4iz square is equal to 4i into x plus iy whole square, and that is equal to 4i into x square minus y square plus 2i xy. Z to power 4 minus mod z to power 4 is equal to 4iz square gives minus 8x square y square plus I into 4x cube y minus 4xy cube is equal to minus 8xy plus I into 4x square minus 4y square. We will equate real part with real part and imaginary part with imaginary part. This gives xy is equal to 1. We have to calculate the minimum value of mod z1 minus z2 square. Suppose z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. So z1 minus z2 is equal to x1 minus x2 plus I into y1 minus y2. Mod z1 minus z2 square is equal to x1 minus x2 whole square plus y1 minus y2 whole square. From this relation, it is clear that if x is equal to 1, y is equal to 1. If x is equal to minus 1, y is also equal to minus 1. We will apply the same logic for x1, y1 and x2, y2. If x1 is equal to 1, then y1 is equal to 1. If x1 is equal to minus 1, then y1 is also equal to minus 1. Similarly, if x2 is equal to 1, y2 is equal to 1. If x2 is equal to minus 1, then y2 is also equal to minus 1. We have to consider real of z1 is greater than 0. That means x1 is greater than 0. And real of z2 is less than 0. That means x2 is less than 0. So x1 is greater than 0 and x2 is less than 0. x1 is greater than 0, so x1 is equal to 1 and y1 is equal to 1. And x2 is less than 0 means x2 is equal to minus 1 and y2 is equal to minus 1. So these are our desired values. We will put these values here. So we get x1 minus x2 whole square plus y1 minus y2 whole square as 1 minus minus 1 whole square plus 1 minus minus 1 whole square, and that is 2 square plus 2 square, or 4 plus 4, and that is 8. So our answer is 8. We will fill 8 here. Last question. Let S be the set of all complex numbers z satisfying mod z minus 2 plus I is greater than or equal to root 5. If the complex number z0 is such that 1 upon mod z0 minus 1 is the maximum of the set 1 upon mod z minus 1 such that z belongs to S, then the principal argument of 4 minus z0 minus z0 bar upon z0 minus z0 bar plus 2i is. These are the options given. This question was asked in JEE Advanced 2019. It is given that z satisfies mod z minus 2 plus I is greater than or equal to root 5. we can write this as mod z minus in bracket 2 minus I is greater than or equal to root 5. This matches with the standard form of the circle. We know that the standard form of the circle is mod z minus z0 is equal to r, where z0 is center and r is radius. Inequality greater than or equal to means z lies either on the circle or outside of the circle. Set S consists of all the elements which are of the form 1 upon mod z minus 1. So elements of S will be something like 1 upon mod z1 minus 1, 1 upon mod z2 minus 1, 1 upon mod z3 minus 1, and so on. We have to find the maximum value of 1 upon mod z minus 1. At maximum, z is equal to z0. So let us first simplify this. Suppose z is equal to x plus iy. So 1 upon mod z minus 1 is equal to 1 upon mod x plus iy minus 1. Or 1 upon mod z minus 1 is equal to 1 upon under root x minus 1 whole square plus y square. In this equation, on both the sides in numerator, it is 1. So maximum value of left hand side will occur when it is minimum value of the denominator of right hand side. So we can say that under root x minus 1 whole square plus y square should be minimum. We know that square of a real number is always positive. That means x minus 1 whole square is greater than or equal to 0 and y square is also greater than or equal to 0. So minimum value of x minus 1 whole square is equal to 0 and minimum value of y square is also equal to 0. So x minus 1 is equal to 0 and y is equal to 0, or x is equal to 1 and y is equal to 0. So we have got z0. So z0 is equal to x plus iy, and that is 1 plus 0i. So z0 is equal to 1 and z0 bar is also equal to 1. Now we have to find the principal argument of this. Here we will put z0 is equal to 1 and z0 bar is equal to 1. So argument of 4 minus z0 bar upon z0 minus z0 bar plus 2i comes out to be equal to argument of minus I. And we know argument of minus I is equal to minus pi by 2. So the correct option is option B. In next video, we will start chapter number 4, and that is quadratic equations. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.